3.8 homework, finding all zeros, rational, irrational, imaginary. So what techniques should you use? Well, factoring is a great technique. Using Desmos to find one of the zeros, then using synthetic division to reduce the polynomial so that you could possibly factor or use the quad formula. So let's start with the first one. I'm going to try to factor by grouping. I don't know, looking at it, if I can. If it doesn't factor by grouping, I'll go to Desmos and I'll find one of the zeros. So I can do a GCF of x squared with x minus 1 plus 9 x minus 1, leaving me with x minus 1 times x squared plus 9. Setting that equal to 0, I'm going to end up with x equals 1. X squared plus 9 equals 0 is going to yield me imaginary solutions. So x squared equals 9. X equals plus or minus the square root of negative 9, which is plus or minus 3i. So the zeros are x equals 1, 3i, and negative 3i. Number 2. Maybe I can do factor by grouping again. I don't know. Let's give it a shot. You just never know until you try. So GCF there is 4x squared. Whoosh, that's a big GCF. Leaving me with x minus 1. No, x minus 4. Right? This one plus 9. X plus 1. Wow. Not even close to being able to factor by grouping. So what do I do then? What do I do? Well, let's put it into Desmos and see if we can find a 0, right? So 4x cubed minus 16x squared. Okay, so 4x cubed minus 16x squared. Okay, I should have picked up the other ones. Let's see, plus 9x plus 9. Plus 9x plus 9. Okay, let's see if we can find one, right? So we've got one at 3, one at 1.5, and one at negative 0.5. So 3, 1.5, and negative 0.5. All right, so let's go back. X equals 3, 1.5, and negative 0.5. Now, we know that the quadratic had 3 zeros, right? So if I wanted to show algebraically where those zeros came from, I would take one of them, so I'll start with this one, and I would use synthetic division. So 3, 4, negative 16, 9, 9. 4, 12, negative 4, negative 12, negative 3, negative 9, 0. And of course, we ended up with a 0. 4x squared minus 4x minus 3 equals 0. So what would you have to do to show algebraically that these are the other two zeros? Well, you would have to factor that quadratic. Again, split the middle, guess and check. Sometimes people don't like guess and check. They might go, oh, 2x minus 3 plus 1. Let's see, does that work? 4x squared minus 6x plus 2x is your minus 4x minus 3. Hey, right off the bat, it worked. When you factor for 35 years, guess what? You get pretty good at it. The next one I'll do split the middle to remind you guys. So 2x minus 3 equals 0, 2x equals 3, x equals 3 over 2. So there's your 3 over 2, which is 1.5, and your negative 1/2, which is negative 0.5. Please, on your test, be able to justify algebraically what you see on Desmos. If you just put the roots down and you don't show me any of this algebraic work, the answer is worth nothing. Maybe 1/2 a point. Okay, number 3. Let's try to factor this. Again, it's a trinomial. It's an x to the 4th, right? So let's try x squared and x squared. And then let's follow our trinomial patterns. What two numbers multiply to be negative 36 and add to be negative 5? How about negative 9 and positive 4? And now I can go ahead and set those equal to 0. So x squared minus 9 equals 0. X squared plus 4 equals 0. X squared equals 9. X equals plus or minus 3. X squared equals negative 4. X equals plus or minus root negative 4. So our factors are 3, negative 3, 2i, and negative 2i. All right, number 4. There are 5 terms, so I have to put this in Desmos. I must start with Desmos. Whoops, I just spelled Desmos wrong. All right, x to the 4th minus x cubed minus 6x squared. Okay, x to the 4th minus x cubed minus 6x squared. What's the next one? Minus 50x minus 100. Minus 50x minus 100. All right, what do we got? We've got a 0 at negative 2, and we've got a 0 at 5. All right, so let's go back. 0 at negative 2 and at 5. But we still have 3 more zeros we have to find, right? No, 2 more zeros. Sorry, it's a quartic. So let's start with negative 2, and let's use synthetic division. 1, negative 1, negative 6, negative 50, negative 100. 1, negative 2, now that was x to the 4th, right? So that means this is x to the cubed. X cubed, I mean. But let's use the next 0, which is 5, with those same bottom row numbers. Okay? I mean, you could put that 0 there at the end, but it's not necessary. 1. Now this is quadratic, all right? So you started with quartic. Your first row at the bottom of synthetic division is cubic. Your next row at the bottom of synthetic division is quadratic. So x squared plus 2x plus 10 equals 0. And so here goes quad formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. And then you got to simplify that. So that's going to be negative 2 plus or minus root negative 36 over 2. And so that's negative 2 plus or minus 6i over 2. And so my other zeros are negative 1, so negative 2 over 2, negative 1, plus or minus 3i. All right, number 5. Number 5 is a cubic, but it is the pattern that we use for factoring, okay? So 2x cubed minus 54 becomes 2 times the quantity x cubed minus 27. So 2x minus 3, x squared plus 3x plus 9. 2 doesn't equal 0, so we just forget about that guy. X equals 3, and then back to the quad formula. X squared plus 3x plus 9 equals 0. X equals the opposite of 3 plus or minus the square root of 9 minus 4 times 1 times 9 all over 2 times 1. 9 minus 36 is a negative 27. Hope I'm doing that right. So negative 3 plus or minus. So break down your negative 27, root negative 9, root 3. So that's 3i root 3. All right. So my first root is 3. The next one is negative 3 over 2 plus 3i over 2. 3i root 3 over 2, I should say. And negative 3 over 2 minus 3i root 3 over 2. If you want to write them together, that's totally fine. You could write them as negative 3 over 2 plus or minus 3i root 3 over 2. Number 6. Let's factor like we would factor a normal trinomial, x squared, multiplies to negative 9 and adds to negative 8. So it has to be subtract 9 and plus 1. Set them equal to 0. X squared minus 9 equals 0. X squared equals 9. X equals plus or minus 3 because you're square rooting. X squared plus 1 equals 0. X squared equals negative 1. X equals plus or minus the square root of negative 1 or plus or minus I. So your zeros, 3, negative 3, I, negative I. Last two. Wow, these are big, long polynomials. Wow. I think I'm just going to put them into Desmos and see if I can find some zeros. So 2x5, 3x4. Get rid of this guy. 2x5 minus 3x4. It's going to take a while to go back and forth. Oh, and it's plus 16x cubed and 27x squared. Oh, I forgot the last term. Minus 18x. All right, what have we got from Desmos? We have a 0 at negative 2, 0, and a half. So negative 2, 0, and a half. That means we found 3 of the zeros. But this is a quintic. So there are 5 zeros. So we're missing 2. So negative 2, 0, and a half. So x equals negative 2, 0, and a half. Was that a positive 1/2 or a negative 1/2? I can't even remember. Positive 1/2. Okay. We're going to have to use those to reduce the polynomial. All right, so let's start with negative 2. It doesn't matter which one you start with. 2, 3, 16, 27, negative 18, 0. 2, negative 4. All right, now I'm going to use the next 0, which is 0. Two. Okay, so now our last one is a half that goes in the house. And so that's 2, negative 1, 18, negative 9, 0. I should have had that 0 there because it was negative 9 times 0 is 0 plus 0 is 0. All right, last one here. Bring down the 2, 1, 0, 0, 18, 9, 0. So where are we at here? Well, we originally start with x to the 5. So this is what I do. I know then that that bottom row is x to the 4th. That bottom row is x to the 3rd, which means that bottom row is x to the 2nd. Also, if you think about it, you're looking for 2 more zeros, so that polynomial on the bottom has to be quadratic. So 2x squared plus 18 equals 0, okay? 2x squared equals negative 18. X squared equals negative 9. X equals plus or minus the square root of negative 9, which is 3i. And negative 3i. So graph your polynomial, find some zeros, and use each one of them in synthetic division to find the remaining zeros. Last one. Again, Desmos. So x fourth minus 3 and minus x squared. Okay. Get rid of that. X to the fourth minus 3x cubed minus, oh, I forgot already, minus x squared minus 27x minus 90. Okay. So x, I think that's right. So we've got a 0 at -2 and at 5. Okay. So x equals -2, x equals 5. Okay. Now, on this one, you see how it says factors? I'm going to go ahead and write the zeros, and then I'll write the factors. Okay. I just want to make sure that we answer it correctly. So -2, 1, -3, -1, -27, -90. 1, -2, -5, 10, 9, -18, -45, 90, 0. Ooh, that was close. I was worried I wasn't going to end up with a 0. Now let's go to the next one. 5, 1, -5, 9, -45. All right, now again, the original polynomial was x to the fourth. That means that this one is x to the third, and that means this one is x squared. So I'm going to end up with x squared plus 9 equals 0, x squared equals 9, negative, x equals plus or minus the square root of -9, which is plus or minus 3i. But how do we write them as factors? Well, we write them as x minus a -2, or x plus 2, x minus 5, x minus 3i, and then if you do x minus a -3i, it's x plus 3i.